Hello, everyone. I'm very glad that join the Distribute Circle Summit Asia. And my topic is solving multi-region data rate and data rate challenges in cross-border payments. In fact, it is a topic about the distributed database solution. At first, let me introduce myself. My name is Zhao Feixiang, and I'm the database architect in Airwallex. I work as a database administrator for many years, just as the Oracle database, MySQL database, Redis, MongoDB, and the other databases. And at the moment so we have many different business requirements. So I worked as the distribute database to solve our business problems. The first question is, why do we need a distributed databases? The answer is that they are necessary and advanced if we use the distributed databases. At first, as a DB, and we can look up the database stages. In fact, the database has 3 stages. The first is that RDBMS. It means the relational databases, just as the some example is MySQL, Oracle, MariaDB, and Postgre. To the main database feature, it can support ACID transactions, circle support, standardized. And at the moment, the RDBMS is the main OLTP databases in most of our companies. And in fact, in my company, we also use the Postgre as the main RDBMS. And then, as the network use the company and more different network use cases, just as the application need very, very fast data rate and data rate, and the other use cases. So at the moment, after the RDBMS, the 2 stage of database technology is about NoSQL. It is at first is non-relational databases. What does the NoSQL can support? In fact, the NoSQL is solve the problems which the RDBMS cannot support, just as the horizontal scaling and heightened availability. It means that in RDBMS, the scaling and HA is different problems to solve because the architecture about RDBMS is different with NoSQL. And NoSQL can solve the existing problems with which the RDBMS can solve. So as a 3 databases technology, it is NoSQL. The NoSQL is what? Just as the example is such as the Cloud Spanner, Cockroach DB, and YugabyteDB. The NoSQL is that it can support what the RDBMS can support, just as the ACID, the SQL support. At the same time, because it also can support the advanced features which the NoSQL can support, just as the scaling and HA. So it means that after the NoSQL is can support most of us, the NoSQL is the 3 stage. It is the advantage and the way which the database should achieve. So the Yugabyte is also a NoSQL. We should to analyze, to test, and if it can apply our business, we can apply it in the production environment. And the next is that if our company or our business is only one data center or two data center, it is very simple to support all the applications and services. But at the moment, if our data center are in different regions, multi-region, I mean that RDBMS will have problem to solve these use cases because multi-region and the single region are very different. The business requirements must depend on the databases. If one region or single region, we can use the single databases can support the application. But if a multi-region, we must have another different architecture or database to serve the business requirement. And to distribute databases, we know that one database cluster must have multi nodes, not a single node. So distribute can read it and read it, especially read it in different nodes. It is a very important feature to distribute databases. So if we have different regions, we need read it in different nodes at the same time, or we need multi-nodes as a one database cluster. We need consider the distributed databases. Or the distributed databases can help us to solve the multi-region data use case. And next is a scale. The scale method of the databases. At first, we also need that. At first, we can set up databases, instances, but as the application improved, the databases need made to the data stats will increase and the workload will also increase. So we must consider the scale. To scale, we always have two ways. One is scale up. It means that at first, if a database instance is about 2 core CPUs and 8 GB memories, and then we need, if the workload reach the limit of the machine type, just as the CPU usage reached 100%, we need scale the machine type, increase the type to 2 cores CPU or 17 cores, 17 GB memory or higher. And 1 year later, if the workload increased very fast and the database also increased very fast, we also need to scale up again, just as increase the machine type to 8 cores CPU or 32 GB memory. This is a scale up. But if the application or service of the workload is still increased, the increase of the machine type will always consider the limit. So scale up is a way, but it has limit, especially the application increase very fast or have a big increase about the workload. But another way is scale out to the single node databases, just as a MySQL and Postgre, because all of the instances can set up only one node. So it can only support the scale up. If we can use the distribute algorithm to apply to the DB, we can, just as a Yugabyte, the database will support the scale out. It means that at first we only have one instance, which the machine type is 4 core CPU and 8 GB memory. And then if the workload increased, we can increase the nodes, but not increase the machine type. Just at first, we only have one node to support the application. And then we can increase the 2 nodes, 4 nodes, 8 nodes, and many nodes. We can scale out to support the databases and applications. It should have advanced features. Just as that, at first, the higher availability and robustness, it means that because the database is running in multi-nodes, if one node or 2 nodes down, the cluster will still can work very successful. But if the single node databases, if the server is down, the database will be down. So if the scale of the distributed database, it can support the HA. And the third very important feature is about scalability. At first it's 1, and then it's 2 and 4. We can scale it. And because the distribute is running on multi-nodes, so if we can upgrade the version, or we can change settings of the database variable, we can rolling upgrade. So to scale the databases, we also consider that the distributed database should be a better choice. Okay, the second question is that at first we know that we should consider the distributed database because it is the latest way for the database distribute. And if we use distribute, we can solve many problems and we can get the very necessary and useful feature in distributed databases. And the second question is multi-regions requirement in Airwallex. It means that what's the use case in Airwallex? What's the challenges about the databases? How can we analyze the challenges and find a way to solve the challenges or solve the problems? At first, I can share that the business background of the Airwallex. Airwallex, in fact, it is a global company, and Airwallex supports financial infrastructure for global business. It means that in the Asia, in the Europe, in the Africa, Australia, and every region, we have businesses, and we help them to pay in or pay out. So at first, because our business is working on multi-regions, so our database also need to support the global multi-region businesses. So this is a basic background of our use case. And this is also a basic background of our database solution. It means that we have different regions, and every region need to read it. And next is the basic multi-region requirement. Because we have different regions, and every region need to read and write. If the business use the Postgre as single database, it can support the single region. But at the moment, we are multi-region. It means that usually we need to use the database, Postgre database and other high availability proxy to support the HA. So HA is also in multi-region. The basic is the HA. The database must can support the higher SLA to make sure that the application can always running. It can not have downtime. To the single RDBMS, we can use the databases and the replications of single method, and then we can use the web server and application to achieve the HA. But after we analyze it, the basic is the master slave will have downtime issue. It's just that if we not use the distributed databases, we use the RDBMS. The RDBMS will have the head check and make sure that the P instance is working or not. So this is a master and slave downtime issue. The second is that manual setup cost many people, because if there are two databases, two Postgre, we also have the third HA solution, but it always need more companies, more people, more DBs to support it. But if we use the distribute databases, and distribute can achieve support higher SLA, because at the moment in distribute there are multi nodes, and the nodes can have date. If one node down and there are no nodes, it still can work. In one regions or multi-AZ, it can support the higher SLA. But in their use case, if the Yugabyte primary cluster set up on different nodes in different regions, and in this case, if one region is down and the other region can still work. This is a basic, and another is the advanced multi-region requirements. It means that at first we have the multi-regions, just Asia, American, Europe, and India, and so on. Just as many services, just account service and other services, in every region, the application need to write it. But at the same time, in the other region, the application also need to write it. And it means that in the master 1 or primary cluster 1, it is in DC1. We need to write it and read it. In the other region, we also need to write it and read it. But we still need a multi-master replication to sync the data to each other. And then the service can write it in the local master, and the every region service and can read global data from a local master. It means that we need the multi-region can read it and read it, especially read it in the local and read it also in local. But the read it not only can read the local data, but also can read the other region data, because if the data can be synced, we can sync each other. At last, after we set up the replication job, after the job is running, every region cluster will have the whole databases. So after we analyze this use case, it is this master and master is very necessary, because consider the performance, every region should have the databases, and every region the application can write data in the instance, in the local instance, and then the data can sync or replica to the other regions. At last, every region can have the data is running. We can use the master and master is necessary, and both the data write and data read can be have performance. And at the same time, because the Basic is the primary cluster. It can also support the HA and the DR. And the third use case in our company business requirement is the multi-region regulatory requirements. In fact, the many countries have the regulations around which geopolitical regions the personal data of the resident can be stored in, and bank transactions being personal data are subject to these requirements. Just as the GDPR is a data requirement statement which requires the personal data of individuals in the Europe be stored in the Europe. And in these cases, it means that we have the multi-regions, and every region can only save the personal region data. And the personal in this region cannot be stored in other regions. But at the same time, just as we need to pin or payout, in every region, we still need to read the data, read the global data. So in these use cases, we should create a global universe, global cluster, but we should have the geopartition. And then every region personal data can be stored in the personal universe, and then it can stored in other regions. And in every region, we can read the global data. So this is the 3 use cases and in our company. The third question is, how can we use the Yugabyte to solve the problems? It means that the YugabyteDB architecture and practice. And first, we still need to consider the architecture. There are 2 things. The important thing is multi-region data rate. Different implementation of multi-rate, we can consider different layer to achieve. Just as the business layer, it means that the programs can control multi-region, multi-node rating. And we can also consider to set up the proxy layer to control the multi-region rate. And in the database, we can also consider the multi-node rate. This is just the Redis cluster, and also a distributed databases, and the client can read it and save the data to it. So consider the 3 methods to achieve the multi-node rate. We can see if the database layer can achieve this, should be the best choice to us. And then multi-region data implements of the data in a single region. If we in a single region, we can consider the multi-point rate, just as the different databases will have different solutions, but the similar architecture, just as if we use the MySQL databases, we can use the MySQL MGR or MySQL InnoDB cluster. And then the cloud provider distributed databases, just as the Google Spanner and Airwallex and the other cloud distributed databases. And third is the database just as a CockroachDB or YugabyteDB. To consider the multi-region data rate, and we testing and do many testing and analyze. At last, we choose the Yugabyte as our distribute in Airwallex. The main consider about all of our existing OLTP database is Postgre, so we must need the distribute database also can support the Postgre compatible. the Yugabyte can support the Postgre compatible. And the other is the HA. HA is a very important, very, very important thing to us. And the third is the horizontal scalability. It means that if the workload or data is increased, our database is also can scale and increase. And last is the geo distribute. This is the 4 important reasons why we choose the Yugabyte in Airwallex. And after we testing, we have different things. Is that the first is the Yugabyte single region, multi-region architecture, and it means that we have a region is that Yugabyte universe, and Yugabyte include 2 clusters. One is the Yugabyte primary cluster, the other the Yugabyte read replica. The primary multi-regions can use one region or in multi-region. The read replica also can be the multi-regions. So it is a primary cluster and the read replica. The second architecture is that multi-region, multi-read as cluster. In fact, it is active cluster. Just as in the data center 1, we have the Yugabyte primary cluster. And the data center 2, we also have this primary cluster. And then we can set up the replicating job in the data center 1 and data center 2. And the replicating job can sync data to each other. And then we can solve or support our business requirements. We can write data in every region and read the global data in the local region. The Yugabyte multi-region, multi-read as cluster architecture, phase 1 or phase 2. The phase 2 is that you can consider different stage of the S cluster. At first, if we only have 2 regions, we can use the 1-to-1 active Yugabyte cluster. But if we have 3 regions or 4 regions, we can achieve the 1-to-1 active Yugabyte S cluster. At last, we have the N-to-N active cluster. This picture is about the 4 regions active cluster. And the third use case is that the Yugabyte multi-geo-partition architectures. Different regions store different data. Local region can be have performance, and every service can read global data. To this is that the global cluster is that can be deployed. Multi-regions can meet HID consistency. If there is across this query, you can increase the read replica for local read to improve the performance. So as summary, we can summarize redeployment architecture of Yugabyte. The first is primary cluster and the read replica. And the primary can be a single region, meaning to achieve high availability. And if the primary cluster deploys the multi-regions, it means to improve DR. And third is Yugabyte Edge cluster. Multi-regions are dependent on primary clusters with good stability and performance. Pay attention to the data complaints. The third is Yugabyte geo-partition cluster. Multi-regions are a large primary cluster, and the table is partition table, which is consists of the data summed in solution. So we have the 3 cases we use the databases in 3 cases and different cases to solve the different problems. And then we can consider and choose Yugabyte to the multi-region data read by Yugabyte. Okay, that's all. If you have any questions, and you can ask me, and I can answer the questions. Okay, thanks very much. Bye bye.